All right, guys, this is going to be my best shot at giving you a study guide for the test that you'll take either on Thursday or Friday of this week. Now, I am going to count your turning this in as a 30% quiz. Now, you don't need to have all the things drawn out in terms of the questions, but you do need to have, question one and whatever work I show on here, I want to see on your paper. Now, ideally, you can print this out to work from, but I'll be honest with you, it's 20 pages because there's 1 page per problem. Now, you could, put 2 to 1 page or something like that, but I will leave that up to you. And at any rate, you can go back and listen to this recording at any time. All right, but here it says in triangle QRS. So we've got some kind of triangle, QRS. Well, I messed up already, and it says R is a right angle. Well, let's pretend. What is the ratio for the tangent of angle S? So you got to remember, right? Tangent is opposite over adjacent. Always, 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 always. So let's look at our choices here. Choice one, is it the measure of the leg adjacent over the measure of the hypotenuse? No, that's not it. Is it the measure of the hypotenuse over the measure of the leg opposite? No, that's not it. Is it the measure of the leg opposite over the measure of the hypotenuse? No, that would be sine. Is it the measure of the leg opposite over the measure of the leg adjacent? Bingo. That's it. All right. Let's keep going here. Number 2, we're to find the value of x and round to the nearest tenth of a unit. Well, we've got an angle 40 degrees. We look at the two sides. I have a hypotenuse and I have an adjacent. So what trig function deals with hypotenuse and adjacent? Well, we're talking about cosine. So we'd say cosine of angle 40 degrees is equal side x over 125. And then we multiply both sides by 125. And that will give us the length of x. And let me get my calculator. And I hope y'all will remember, what do you have to adjust in your calculator before you do any trig? You have to go to mode. Let me show it here one more time. Here's the mode key. Well, you can't even see that. All right, here's the mode key right there. You go in it and make sure, and yeah, mine's already been highlighted, degree. So I'm good to go. So I'm going to type in 125 cosine 40, hit enter, and it's 95.8. And so that would be that first one right there. All right, let's go to problem 3. Again, there are 20 problems, so and on the test there'll be 20 problems. And I put this study guide together myself, and as far as I know, everything on here is what's going to be on the test. It's going to look slightly different, obviously, but so what is the height of the parallelogram? All right, so in other words, they want to know how high is that right there? Well, don't let this weird thing shake you up too bad. All right, a parallelogram, that means if this side is 8, this side is 8. So all you got to do is focus on that triangle. And so what we're doing, and that's 19 degrees, so we've got an opposite and a hypotenuse, so that's going to be sine. 19 degrees is equal opposite over hypotenuse. So we multiply both sides by 8, and that will give us the height. So let's see, 8 times sine 19 is 2.6. And so that would be right here. Again, we're rounding to that 10th spot. All right, question 4. Okay, in a 45, 45, 90 triangle, if the length of a leg is 8, the length of the hypotenuse is, now some of y'all already know it's got to be this one, 8 square roots of 2. But I am a big believer in sketching geometry problems out. So here you've got a 45, 45, 90. And we know if one leg is 8, the other leg has to be 8, and the hypotenuse has to be that length times the square root of 2. So you guys got to have access to these, the 30, 60, 90 triangles and the 45, 45, 90. In fact, let me do a super quick sketch of both. There may be one later on, I can't remember, but we'll find out. So this is a 45, 45, 90. If that side is x, this side is x, that side is x squared, it's a 2. And over here we've got a 30, 60, 90 triangle. If this side, the side across from the 30 is x, the side across from the 60 would be x squared, it's a 3, and the hypotenuse would be x times the number 2. Y'all can't see that. Alrighty, well, let's go to question 5. All right, you've got I'm trying to think if that's definitely a square. Actually, we're going to assume it is a square, but they needed a right angle in there to prove it. But that's beside the point. Each angle here would be 90 degrees. So if that cuts it in half, then that part x is going to be 45. Okay? And let's see here. What else do we need to know? We're trying to find... Oh, okay. And if this is a 45, this would be a 45, 45, 90 triangle also. So if this leg is 13.1, that leg is 13.1, and this is 13.1 times the square root of 2. So let's see, that's going to be right here. That's going to be D. D. All right, question 6. Notice, hint, use the Pythagorean theorem. Sometimes we get too quick into the trig and we forget that we can use the Pythagorean theorem. Find the length of the missing side. Simplify in radical form. All right, so let's just call that side x. Well, we're given the hypotenuse, 18. So we know that 18 squared will equal the 2 legs squared added together. And let's see, 18 squared, what would that be? 18 squared is 324. So 324, set that equal to 11 squared is 121 plus x squared. So we'll subtract 121 from both sides. And we get 203 equals x squared. Now I'm pretty sure in my own head that that's, as we take the square root of both sides, that's in simplest form, but I'm going to cheat and look up here and see if that answer is there, and sure enough. So I don't need to try to put it in the calculator and see if there's any perfect square factors of 203. All right, let's go to number 7. I like these problems, but some of y'all may not, but I do. All right, find the angle of elevation of the sun when a pole 25 feet tall casts a shadow 42 feet long. All right, so we got the sun here. Nice sun. And we've got a pole here. And it's 25 feet tall. and the shadow is 42 feet long. So what they're trying to get us to do is to get smart here. And find the angle of elevation. Well, that's got to be this here. We'll call that angle X, because remember, elevation is always in relation to a horizontal. So it's going up, so it's elevation. So in other words, we want to find that angle. Well, we're now remembering that if we want to find an angle, we use inverse trig, not regular trig. We use regular trig to find a length. If we want to find an angle, we use inverse trig. So we'll say that that angle is, all right, now what trig function are we going to use? Well, we have an opposite and an adjacent, so that can only be tangent. So we're going to do inverse tangent of opposite over adjacent. And use our calculator. Remember, because it's inverse tan, you have to hit the blue key first. Oops, already opened up, I messed it up. Let's try it again. 25 over 42. And I get 30.76 approximately. So that would be 30.8 rounded off. Let's see if that's one of our answers. Yep. 30.8. I hope y'all like the drawing of the sun. I thought that was pretty good. All right, question 8. The length of the shorter leg of a 30, 60, 90 is 3. Find the perimeter. Oh, okay. So perimeter means we're going to have to find all 3 sides and add them up. All right, so let's draw us a 30, 60, 90. Now, the shortest leg would go with the shortest angle, so that's going to be 3. The side across from the 60 will be 3 times the square root of 3, and the hypotenuse will be 3 times the number 2, which will give us 6. So what are we adding up? We're going to add 6 plus 3 plus 3 square roots of 3. And I think you can see pretty quickly that that's going to be 9 plus 3 square roots of 3. Because this 3 is multiplied here, you can't just add those together. So let's see, up above, that looks to me like we're talking about that one right there, 9 plus 3 square roots of 3. I would ask if there are any questions, but y'all can't interact with this recording anyway. All right, so we got square ABCD has a diagonal length of that. What is the area? Okay, well, let's remember, area is length times width, but because this is a square, it's going to be side times side, or we could say side squared, but we'll get to that in a minute. So let's draw us a square. And it has a diagonal length of 7 square roots of 2. All right, well, this should be jumping out at you. If that's, okay, what may not be obvious, this has to be 45, 45, 90 if it's a square, because half of 90 is 45. So if the hypotenuse is 7 square roots of 2, the legs had to be the number 7. Because remember, you multiply 7 times the square root of 2 to get the hypotenuse. So what that means is all 4 sides are 7. So the area then would be 7 times 7, which would be 49 units squared. So let's see, that would be that one right there. All right, number 10. Oh, okay, we got 2 on this side. All right, it says a triangle has side lengths of 14, 48, and 50. Is it acute, obtuse, or right? Well, we don't know, but take the biggest number, in this case it's 50, square it. You're using the Pythagorean theorem setup. So is 50 squared equal to 14 squared plus 48 squared, question mark. Now, if the two are equal, then it's a right triangle. If this side is smaller than the right side, it's an acute triangle. On the other hand, if this side is bigger, it's an obtuse. So let's see what this is with our calculators. So we got 50 squared is 2,500. I'm going to leave a space here to determine in a minute what that is. All right, 14 squared plus 48 squared. I'm doing that all at once. That's 2,500 also. I actually was thinking it would not be, but I was wrong. So this is a right triangle. And I see I've got too many answers there, but that's besides the point. So it would be answer A for right triangle. Okay, question 11. It's looking like a 30, 60, 90 degree triangle to me. We got a 60 there, a 90, so this one has to be 30. Find the value of the variables. Okay, if the answer is not an integer, leave it in simplest radical form. Well, in this case, we're trying, this piece of cake. We're trying to find the side across from the 60. So we use the side across from the 30 times the square root of 3. And that should be the answer right there. Yep, that would be D. All right, that was question 11. Let's go to 12. Find the length of the leg. Well, they're getting tricky here. They're wanting to see if you're going to use trig, because if this is 45, that's the hypotenuse. No, okay, I'm wrong. This is a 45, 45, 90 triangle. So if this is the hypotenuse, let's call this L for leg. How did we get 16? Well, we said L times the square root of 2 got you 16. And we divided both sides by the square root of 2, like so. But then we have to rationalize it because we've got that radical in the denominator. And then we're going to multiply side by sides. So up above we have 16 square roots of 2 in the numerator. Down below we have square root of 2 times square root of 2, which is the square root of 4, but what is the square root of 4? It's the number 2. But y'all notice that 16 does divide evenly by 2. So this correct answer should be 8 square roots of 2, and that would be B. 8 square roots of 2. All right, question 13. Oh, this one's easy. Find the cosine of angle A. All right, so you gotta make sure you're dealing with the correct angle. All right, so cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So it's going to be 72 over 75. Well, I don't see that there, so that must mean that they can reduce. So I'm going to, rather than try to hurt my head figuring it out, I'm going to type in, what was it, 72 over 75? And hit enter. Y'all can't see that, but trust me. Then you go up here to the math key. The first choice is number 1, frac. You hit that, and then you hit it a second time. And that got me 24 over 25. And that would be answer, I almost grabbed the wrong one. 24 over 25 is right. Right there. All right, question 14. Find the missing side. Well. Okay, we have no angles given us. So this is a Pythagorean theorem problem. Let's call that X. So we're going to take the hypotenuse and square it, set it equal to that leg squared plus the other leg squared. And let's see, 25 squared is 625. Set that equal to x squared plus 24 squared is 576. So I'll subtract 576 from both sides, and we get 49. Okay, that's easy. So if 49 is equal to x squared, take the square root of both sides, and x would equal to 7. So which one of those? That would be C. All right, question 15. The length of a diagonal of a square is 15 square roots of 2 millimeters. Find the perimeter. Okay, this is similar to one we did before where we were finding the area. So this one is really easy too. The diagonal is 15 square roots of 2, which means the sides had to be 15. Because remember that this is a 45, 45, 90 triangle. So if the side is 15, 15 square roots of 2 is the hypotenuse. So that would be 30 plus 30 is 60. And that would be answer C, 60 millimeters. All right, let's keep on rolling. Question 16. Find x to the nearest tenth, and that's a number 67. So what is this? This is an opposite. No, yeah, this is an opposite, and that's a hypotenuse. So we're talking about sine. Is that really 67 or 87? Yeah, that's 67. We're going to say the sine of 67 is equal to x over 20. Multiply both sides by 20. And let's see, 20 times sine 67 degrees is 18.4. And that would be that one right there. All right, let's go to number 17. All right, 17 says that the diagonal PR divides rectangle RQ. What? RQRS? Well, they messed up. But anyhow, it's dividing that rectangle into two congruent triangles. So what is the length of segment PR in feet? Okay, in other words, they want the hypotenuse. So that's easy enough. This is an adjacent side. That's the hypotenuse, so we're dealing with cosine now. So we're going to say cosine of 30 degrees is equal to 12 over the hypotenuse. Okay, now this is the type where it involves an extra step because we have to first multiply both sides by x to get it out of the denominator. Then we're going to divide both sides by the cosine of 30. And so we just do that in the calculator. We do 12 divided by cosine 30 and hit enter. 13.9. What? I don't get it. Oh, okay. They wanted us to use a 30, 60, 90. All right, well, I'm going to cheat. Let's see. What I'm going to cheat and see if 4 square roots of 3 is what I just got. So we're going to do 4 square roots of 3. No, that's not it. Let's try 6 square roots of 3. 6 square roots of 3. No, that's not it either. Let's do 8 square roots of 3. 8 square roots of 3. Yeah, that's it. So 8 square roots of 3 was the answer. Now, what was the right way to have done that thing? Well, I should have recognized that that's a 30, 60, 90. And the side across from the 60 is 12. So how did you get 12? Well, you took this side, x, That's still not making, well, let me finish it up. All right. So we've got x times the square root of 3 is equal to 12. All right. So dividing both sides by the square root of 3, we get here. Rationalizing the denominator, we get 12 square roots of 3 over 3, which is 4 square roots of 3. Okay, so side x is 4 square roots of 3, which the hypotenuse will be that times the number 2. And that gave you 8 square roots of 3. All right, that was the official way to do it. I went at it through other trig way and just kind of cheated. I multiplied those until I found what I knew was the right answer. All right, so let's go 18. Oh, good, more of these sketching ones. I like to sketch. All right, a person is standing 40 feet from a flagpole and can see the top of the pole at a 35-degree angle, but his eyeball is 4 feet from the ground. And let's see, he's standing 40 feet from it, flagpole. And from his eyeball, $35. So we know this side is 40. We're trying to find this side here, and then we're going to have to add 4 to it. So we've got an opposite and an adjacent. So that would be tangent 35 degrees is equal to x over 40, multiplying both sides by 40. We get x. So let's see here. 40 times tangent 35. All right, that's 28 feet approximately. But we add 4 to it, and we get 32 is the correct answer. Now notice they got sneaky. They put 28 there as one of the possible answers, but you need to add 4 to it to get the 32. All right, 39. All right, so square ABCD. ABCD has a diagonal of 14 feet. Find the length. Well, that's easy enough because this has got to be a 45, 45, 90. So how did we get 14? Well, we took the leg times the square root of 2, and that got us the 14. All right, so we're going to divide both sides by the square root of 2, then rationalize the denominator, and that gives us 14 square roots of 2 over the number 2, and 14 divided by 2 is 7 square roots of 2. And that would be the top answer right there. All right, and last one, question 20. Wants us to find x and y. Well, I hope I can be a little smarter this time than I was last time. It's hard to know, though. All right, so there's a 30, a 60, and a 90. Well, what we're given is 36. That's the hypotenuse. And we know that the side across from the 30, x, times 2 got us 36. So divide both sides by 2. That length is 18. And then the side across from the 60 would be 18 square roots of 3. So that looks to me like that would be B. Let me check the other answers real quick. Yeah, okay. So that would be B. All right, guys. I'll be available, I assume, today and tomorrow's Wednesday to answer any questions on this. But again, by Wednesday evening, I need to see this thing, all your work shown, for a major quiz grade, a 30% grade. But we'll talk with you later.